Okay, today we're going to be looking at 4.1, which is the start of our exponent rules. We'll actually spend 2 days on this, but today we're going to look at 3 rules, and I think tomorrow we look at 2 more rules. But the first rule we're going to look at is that when you're looking at exponents, when you multiply exponents, you really add them. So what that means is if you have a problem like x to the second, that's an exponent of 2, times x to the third, the biggest mistake most people make is they want to multiply because that's multiplication. But for exponent rules, when you multiply exponents, you really add them. So the really answer is x to the 2 plus 3 is 5. So when you multiply exponents, you really just add the 2 exponents. And the reason why is if you think about x squared, what x squared means is that you have 2 x's. And x to the third means you have 3 x's. So altogether, we actually have 5 x's. So that's where the property comes from. So if you can't remember, you can always draw it out, but of course the quickest, easiest way is to use the rule. So when we look at x to the third times x to the fourth, because we're multiplying, they do have to have the same base, but since both of these have the same base of x, then we can just add the exponents and say x to the 3 plus 4 is 7. Then the same thing with this next one. Now it's not an algebra letter, but it's a base of 3. So we have 3 to the second times 3 to the fifth times 3 to the sixth. So since all the bases are the same, you just leave the base of 3 and then you add all those exponents. So you say 2 plus 5 is 7. 7 plus 6 is 13. And then this next one, we've got 3 of them. But again, because they all have the same base, you can just add the exponents. So this is x to the 4 plus 3 is 7. 7 plus 2 is 9. So when you multiply exponents, you really add them. The next rule is that when you have a power to a power, you multiply. And so what that means is that's an example like x to the second to the third power. This is x to the second power, and then all of that is to the third power, and that's considered a power to a power. Let me draw a line over here. And when you have a power to a power, you multiply those, and your answer is x to the sixth. So you just say 2 times 3 is 6. Now the reason this is different than this one, this 3 says I have 3 of these x squared. So if you broke this up, that's telling me I have 3 of those. This rule then says you would add them, 2, 4, 6. But you can also think of x squared means there's 2 of those. So how many total x's do we have? 6. So that's where that power to a power rule comes from and why you multiply them. So here's some examples of that. This is x to the second to the fourth power. It's a power to a power, so we're going to multiply those and say x to the 2 times 4 is 8. This one, it's the base of 4 to the 5 times 2 is 10. Now this one, we've got 2 things inside the parentheses with a power of 4 to the outside. So this is really, if it doesn't have an exponent, it's assumed to have an exponent of 1. And so this 4 has to go to both of those things. And for a power to a power, you multiply. So this is really 2 to the 1 times 4 is 4. X to the 1 times 4 is 4. Or the shortcut is just to know that that 4 is going to come to both of those things inside there. And if it doesn't have an exponent, the exponent is 1. So this one has a shortcut. I just know that the 2 is going to go to the 3, the x, and the y. So it's just 3 to the 2, x to the 2, y to the 2. Now this next one, the 2 only goes to this x and y because that's in parentheses to the second power. This 7 is just going to come down. So since it's out by itself, the 2 doesn't go to that. The 2 just goes to the x and y. So the 7 comes down, and then it's x2, y2. Now when you have a fraction, just like we've done before, the 2 is going to go to the top and the bottom. And so this is just 1 squared over 3 squared. Now the book is letting you leave it in exponent form because they're assuming that you don't have a calculator. And 3 squared is 9, and if you changed it to 1/9, that'd be perfectly okay, but you don't have to. They're letting you leave it as an exponent, because who wants to figure out 3 to the 13th? You'd have to multiply that 13 times. 3 times 3 times 3 times 3 times 3 times 3 times 3, you know, it's just, it takes too long. So they're letting you leave your numbers as an exponent. This next one, a lot of people, this one confuses. So I have x over y to the 5th power. So really the 5 is going to go to both of these, but this y does not equal 0 bothers people. And really it's kind of like just a legal statement, because if y was 0, then your answer would be undefined. And because you can't divide by 0. So if the bottom number was 0, your answer would be undefined. So this is a way of them saying, what's the answer besides undefined? So you're going to just assume it's not 0. So this would become x to the 5 over y to the 5. And again, you can kind of just ignore that. This next one, this is actually all one problem. We're going to get rid of our exponents first, just like order of operations says do parentheses and then exponents. So we're going to do our exponents, make this a 3 to the 2nd and this a y to the 2nd. We're going to get rid of this exponent, making that a 3 to the 4th and a y to the 4th. But then we've got to combine like terms. So because these both have a base of 3, we can multiply them. And when you multiply exponents, you really add them. So 3 to the 2nd times 3 to the 4th is 2 plus 4 is 6. And then you do the same thing with the y's. Y to the 2nd times y to the 4th is y to the 6th. For that, you're doing 2 steps. You're first getting rid of your power to power, and then you're doing your multiplying rule. This next one, again, we've got our parentheses to the 2nd power, so you just have to remember this 2 goes to everything, even if it doesn't have an exponent. It goes to the 9, it goes to the x, it goes to the y, and it goes to the z. So we can say that's 9 to the 2nd power, x to the 3 times 2 is 6, y to the 2 times 2 is 4, and z to the 2. Because remember, it's like a 1 there, so 1 times 2 is 2. Now the last rule is a negative rule, and the rule is that a negative to an even power is always positive, and a negative to an odd power is always negative. So let me explain to you what I mean by that. So if you had a -1 to the 2nd power or a -1 to the 3rd power, let's make this a 4th power. A -1 to the 4th power or a -1 to the 3rd power. To the 4th power, that would tell us we have 4 -1s. But every 2 negatives, a negative times a negative always gives a positive. So that's going to give a +1, that's going to give a +1, and a positive times a positive is a positive. So when you have a negative to an even, it's always going to become positive because an even number of negatives make a positive. But when we look at -1 to the 3rd power, that's -1 times -1 times -1. That's just 3 of them. Well, here, -1 times -1 is +1. So we still have left this -1. And then a positive times a negative is a negative. So anytime you have an odd exponent, it's always going to leave one negative behind, which is going to make the answer negative. So an even power is always going to be positive, and an odd power is always going to be negative. So the way you're going to use that is, let's look at this problem right here. So this 3, you have to think of the negative as kind of its own entity. So the 3 is going to go to that negative, and the 3 is going to go to the 4. And so first you're going to think a negative to an odd is going to leave a negative, because 3 negatives is going to leave a negative. And then you have the base of 2, and then a power to a power you multiply. So 4 times 3 is 12. And that's your answer. So it's all about this being, I was looking at the next problem, this being odd makes your answer negative. But this next problem, do you see this is an even number, so our answer is always actually going to be positive, because this 4 has to go to the negative and to that 5. So a negative to an even is positive. You don't have to write the positive. I'm just going to write it there so you'll know we thought about it. And then 2 to the 5 times 4 is 20, because when you do a power to a power, you multiply. Okay, this next one, the same thing. This 5 is going to every single thing in the parentheses. So it goes to the negative, it goes to the 4, it goes to the x, it goes to the y, and it goes to the z. So you have to think a negative to an odd power, because 5 is an odd number, is going to be negative. Then 4 to the 5th power, x to the 3 times 5 is 15, y to the 4 times 5 is 20, and z to the 5. And that's your answer. This next one doesn't have any negatives, so we don't really have to worry about that. We just got powers to a power. So remember, power to a power, you multiply. So y to the 2 to the 3 is y to the 2 times 3 is 6. And this is y to the 3 times 4 is 12. But now you have two y's that we can combine. So this is y to the 6 plus 12 is 18. Because we're going back up to the beginning that when you multiply exponents, you really add them. So you want to combine any like bases. Y's with y's, x's with x's, and so on. Which brings us to this next one, which is the same thing. We just got 2 of them here. So we're going to take this 3 and it's going to go to the 3, the x, the y, and the z. So this becomes a 3 to the 3, an x to the 2 times 3 is 6, a y to the 3 times 3 is 9, and a z to the 3. Then this next one, the 2 is going to come to both of those, so it becomes an x to the 4 times 2 is 8, and a y to the 4 times 2 is 8. But now we need to combine like terms, so there's not another 3, so that's just going to come down. But you do see that we have an x to the 6 and an x to the 8, so we need to combine those. And when we multiply exponents, we really add them. So we say 6 plus 8 is 14. Then we do our y's, do 3 things underneath those. Those are the same. So I can say y to the 9 plus 8 is 17. And then just don't forget that z to the 3rd has to come down also. So our answer is 3 to the 3rd, x to the 14, y to the 17th, z to the 3. Now this next one's going to use every single rule. So the first rule is this power to power. This 4 is going to go to the negative, the x, and the y. So I'm going to say a negative to an even power is positive. Again, you do not have to write that positive. I'm just writing it there to let you know that we got rid of it. And then x to the 3 times 4 is 12, y to the 4. Because remember, that's like a 1 there, so 1 times 4 is 4. And then it's multiplication here, so it's kind of like we're timesing. And then we're going to do this one. So this 3 is going to come to every single thing. So a negative to an odd power stays negative, and then x to the 4 times 3 is 12, y to the 5 times 3 is 15. But now we've got to multiply what's left, so we've got to do our signs. A positive times a negative is a negative. And then x to the 12 plus 12 is 24. And y to the 4 plus 15 is 19. Because we have to combine those like terms. We had to add our x's and we had to add our y's. And then the last one is an example with a fraction. Remember, this x does not equal 0 just means that what is your answer besides undefined. So you really don't have to pay much attention to that. You just know that they actually want the answer for it. So this 2 is going to go to the 3, the x, the y, and the z. It goes to every single thing. And remember, for a power to a power, you multiply. So this is 3 to the 2nd, x to the 2 times 2 is 4, y to the 3 times 2 is 6, then we go to the bottom, z to the 4 times 2 is 8. So that's our first 3 exponent rules. We'll be learning more in 4.2, but you're now ready to do the 4.1 practice problems.